Okay, good morning or good afternoon. I hope this will be helpful to you. You've already gotten your homework video seen, I'm hoping, so that we make sure we're clear on how to simplify radicals so that we can multiply and add and subtract them. If you should also have your graphic organizer out, so this is on the back side of that. And first we're going to talk about multiplying radicals. So we can multiply radicals if they have the same index. Okay? And then we have the steps to multiplying radicals. The first step is to multiply the numbers on the outside, and then multiply the numbers under the radical, and then simplify, which we've already talked about simplifying. So I'm going to give you about 30 seconds to write those notes down, and I'm going to work through examples. Okay, you should have those written down by now. So I'm going to work through some examples to show you exactly what I mean. So the first example that you see on your paper, and I'm just going to write them on this other paper and work through them since I already have them worked out underneath here. We have the square root of 3 times the square root of 3. So if we do step 1, we multiply what's on the outside. So 1 times 1 is 1, so we don't have to write that. Multiply what's under the radical. 3 times 3 is 9, so you have to keep that under the radical. 3 times 3 is 9. Well, we know the square root of 9 is 3. That's one of those perfect squares. If you didn't, you did 9. 2 won't go in there, but 3 will. Remember our primes, how we go through the simplifying process. 3 goes in there 3 times, and so you have a pair of 3s and nothing left over. So the answer to that one, your example on your paper there, is 3. Okay, over here, we have 2 on the square root of 12 times 4 on the square root of 15. So again, step 1 is to multiply the outside. 2 times 4 is 8. Multiply the inside, and I'm going to cheat just a little bit. I think that's 180. I don't have my calculator out. Yep, it is 180. Okay, so remember, now all we have to do is simplify. We have a number on the outside, so we bring it over, and then we have to break down this into the prime factorization. So 2 goes in there 90. 2 will go in there 45 times. 2 won't go in there, but 3 will 15 times. And then 3 goes in here 5 times. So we have a pair of 2s, so I bring a 2 out how many times? Once. Remember, if I have a pair, that's one pair of 2s. So I have 2 to the first. And then I have a pair of 3s, so I write it down one time. Remember, I'm multiplying all these together now. And then I have a 5 left over, so it goes inside. So 3 times 2 is 6, times 8 is 48 on the square root of 5. I'm going to give you a second to get that written down on your examples there, and then I'll do the other 2 examples for the multiplying. Okay, the next example we'll do, and we'll slide this up. You should be able to see your notes on your own paper now. We have square root of 3 times 3 plus the square root of 6. We're going to have to use the distributive property here. So when I do square root of 3 times 3, this number that's not under the radical goes on the outside. So I have 3 on the square root of 3. And then I multiply this. Notice that numbers on the outside. 1 times 1 is 1. And then I'm going to bring down my plus sign. Under the radical, 3 times 6 is 18. Well, I know this will break down into a factored form, so I can simplify this radical is actually how I should work that. I'm not going to do anything to this one because I can't simplify square root of 3. So 3 on the square root of 3 plus. Come over here to the side and simplify this radical. 2 goes in there 9. 3 goes in there 3. So I have a pair of 3s that will be on the outside as a 3. And then I have the 2 that has to stay underneath. Now, when we get into the adding and subtracting in a minute, since we're adding, if it doesn't matter what the number on the outside is, just pretend that's like 3x and then this is 3y because these are not the same. So if this was square root of 3 and this was square root of 3, then they would be the same radical and we'd be able to combine those. But since they're not, it's just like if you had 3x and 3y, you wouldn't be able to combine them. So we are done with that one because that's as far as we can go with that. Oh, and it froze. Hold on, y'all, sorry. Okay, now this other example, we have 3 plus the square root of 3 times 3 minus 4 on the square root of 3. Again, we can do full method. We can just think about it as distributive property. I'm just going to distribute. 3 times 3 is 9. Remember, full is distributive property, but we'll think of it this way. So 3 times 3 is 9. And then 3, now positive times negative is negative. 3 times 4 is 12. And then I have this radical, but I don't have one here, so I'm going to write it right here. And then I've distributed the 3, so now I'm going to do the positive square root of 3. So positive times positive is positive. There's the number outside of the radical, so 3 times 1 is 3. And then that's the only number under the radical, so I bring down that 3. So 3 on the square root of 3. Then I multiply square root of 3 times this term. Positive times negative is negative. 1 times 4 is 4. And then I have a radical. 3 times 3 underneath is 9. Okay, I can simplify this one. I can't simplify these, so I'm going to bring them down. 9 minus 12 on the square root of 3 plus 3 on the square root of 3 minus, okay, look at this one. That 9 simplifies. We already know square root of 9 is 3, but if you don't, you need to practice breaking that down. 3 goes in there 3 times. So we have 4 times 3, which is, I'm going to write it again, 9 minus 12 on the square root of 3 plus 3 on the square root of 3 minus 12. Then we are actually going to get into combining our like terms here. So I'm going to have to, let's look at what are like terms. And we want to work with the numbers first. So I'm going to combine the 9 and the negative 12, which is negative 3. And then, since that is a square root of 3 and that is also, that's like saying negative 12x plus 3x if those were variables. So the same principle applies. We will combine those coefficients there. So I have negative 12 and 3 is negative 9. I do not change this radical just like I wouldn't change an x. And so that is my answer. I'll give you about 15 seconds to write that down. Okay, all right, that should be enough time. All right, now let's look at adding and subtracting. So when we're adding and subtracting like radicals, I pretty much just told you what to do on that. So you can only combine like radicals, just like we have like terms. And of course that just froze on me again, so hold on just one second. Okay, so we can only combine like radicals. Like radicals, go ahead and fill that in. All right, like radicals have the same index and the same radicand. All right, so basically when you're combining like terms with variables, they have to have the same variable and the same exponent. So when you're doing radicals, you have to have the same radicand and the same index. So it works the same way. All right, so here is key. Simplify everything first, just like we did on that previous problem when we were doing the multiplication. Simplify every radical first, if it can be simplified. Then you can combine like radicals. So to combine like radicals, you add the coefficients and keep the same radical. So to combine like radicals, you add the coefficients and leave the radical alone, just like we talked about in that previous problem. Okay, so now I'm going to do these two examples. So we have 2 on the square root of 45 minus 2 on the square root of 5. All right, so if you, hold on one second here. I'm sorry. All right, so we can look at this radical and see it can be simplified. So what I'm going to do is go ahead and bring down this 2 and a multiplication sign from the outside. I'm going to come over here and simplify the 45. 2 won't go in there, but 3 will go in there 15 times, and 3 will go in there 5 times. So we have a pair of 3, so I bring out a 3, just one of them. And then what has to stay inside? That 5 does. Okay, I can finish simplifying that. You multiply what's outside, you get 6, keep the radical, so you have 6 on the square root of 5. And then that is simplified, so let's go to the next part. We cannot simplify that radical, so we just simply bring it down all the way down here with the other one. And so now I see that the radicand is 5, and they are both square roots, so I can combine those. So I combine those coefficients. 6 and negative 2 is 4. So I have 4 on the square root of 5 because we don't mess with that radical. Okay, give you about 10 seconds there. Okay, let's look at the other example. And it's a little bit longer, so we have negative 3 on the square root of 12 plus 3 on the square root of 3 plus 3 on the square root of 20. That is a plus sign there. I know it almost looks like a division, but you know we hadn't done any division, so that wouldn't even make sense. All right, this can be simplified, but we are going to have to bring down the negative 3 in the multiplication symbol or sign. So we take the 12, and 2 will go in there 6. 2 will go into 6 3 times, so we have a pair of 2's. So I bring that 2 out, and I have to leave the 3 under the radical sign, so it's that's your radicand. I'm going to go ahead and finish simplifying this. So negative 3 times 2 is negative 6, and keep the radical. Let's go to the next one. So I'm just looking at this one now. That square root of 3 cannot be simplified, so all I'm going to do is bring it down here and to that final line there. Then I look at this one. That 20 can be simplified, the square root of 20. So I do 20. Make sure you can see this. I'll slide it up a little bit. Remember, simplify everything first. Okay, so now looking at this one, square root of 20. 2 goes in there 10, and 2 goes in there 5. I circled a pair of 2's. All right, I messed up by skipping a step. Don't make this mistake like I just did. Before you do that, since there's a number outside, so that you won't forget to bring it down, go ahead and do that first. So have a plus 3 times. Now, I'm going to bring this 2 out here, and then I have that 5 left under the radical. So I need to multiply that. So I have plus 6 on the square root of 5. Now you will notice I have square root of 3, square root of 3, and square root of 5. So that's like having negative 6x plus 3x plus 6y. So I can combine these. So I have negative 6 and 3 is negative 3 on the square root of 3, and then just bring down the plus 6 on the square root of 5, and since you cannot combine those, you are done with this one. I'll give you a second to do this. Okay, so now what I want you to do is page 105 and 107. 105 is dealing with the multiplication. 107 is dealing with your addition and subtraction. You need to go ahead and finish both of those pages. So remember that Monday when you come in, we've already gone over your homework from Wednesday, so you should have 105 and 107 complete, and you should also have that study guide I gave you on Wednesday complete, except for problems number 11 and 12, because we're going to discuss those two problems on Monday. If you were absent on Wednesday and have not already gotten your stuff out of the folder, go check the folder because I have it in there with your name on it. Okay, I hope y'all do well on this, and I will see y'all Monday. Thank you.